You are given exactly 60 seconds to answer this question. If you're done with your answers, you can skip the timer and proceed to the discussion portion to verify whether your answers are correct or not. If you may, you can share your answers as a comment in the comment section below. If you need more time, you can pause this video in any moment you want. Your 60 seconds starts now. There are 3 different questions for this item. We need to work on them step by step. We can easily answer B and C when we start with A because it's the angle or the arc we're looking for. But before we could talk about that, there are restrictions here and they are given already. Let's illustrate this given using our unit circle. For this given unit circle, we know that the entire revolution is 2 pi. And we have the restriction that the theta is just within 2 pi. That restriction tells us that we will no longer talk about other arcs after 1 revolution, because as we all know, there are a bunch of coterminal arcs if you're going to have other revolution or double the revolution, even the negative movement for moving clockwise. So we're just strictly on 0 to 2 pi. Another thing here is sine is equal to square root of 3 over 2. If we talk about square root of 3 over 2, sine, that's the y here. So it's a little bit closer to y. Somewhere here and here. That is what we could locate our square root of 3 over 2. Okay? So, however, our sine is positive. So it's just between quadrant 1 and quadrant 2. Okay? And aside from that, we are given that our cosine, it must be less than 0. Okay, so let's take into all of that into consideration. But first, let's try to show our cosine. We know that in our unit circle, x squared plus y squared is equal to 1, and that the representation of x squared is cosine, is cosine. So we have here the cosine squared theta plus your sine squared theta. Okay, squared theta is equal to 1. Since we are given with sine, we can use this formula to solve for cosine. Even if cosine is not what is asked here, understanding the combination of sine and cosine will tell us the location of the terminal point of our arc and the arc itself. So let's try to plug in here the values. You have here cosine squared. Take note of this notation, that means we are squaring it. Our sine is square root of 3 over 2, right? You square that, equal to 1. In short, cosine squared theta plus the square root of 3 is 3, the square of 2 is 4, is equal to 1. Continuing the process, cosine squared theta is equal to 1 minus 3/4, which will give us a result of cosine squared theta being equal to positive 1/4. But of course, we're solving for cosine, not cosine squared. If we take the square root of both sides, cosine theta is the positive and negative square root of 1/4, which will give us a result of positive and negative 1 over, square root of 1 is 1, square root of 4 is 2. So there are 2 possible values for cosine theta, which is positive and negative 1/2. However, we are restricted that our cosine theta must be less than 0. In short, the final answer for our cosine theta is just equal to the negative of 1/2. Okay? It's the negative of 1/2. This would mean that our combination, or the theta, could be located, okay, our theta will have the coordinate of a combination of our cosine, negative 1/2, and our sine, which is square root of 3 over 2. Where could we locate this? So negative 1/2 is somewhere here, and square root of 2 again is closer to that. This is the point. This is the terminal point. If you can still remember, this is actually a special coordinate of 2 pi over 3. Okay? 2 pi over 3, and that's the value of our theta, because the coordinates of 2 pi over 3 is equal to negative 1/2 and square root of 3 halves. Okay? We don't have other options as to that. Of course, we know that it's negative 1/2 and positive square root of 3 over 2. So we can have here 2 pi over 3. And this is our A. Already done with letter A now. Once you're done with that, it's easier for us to solve our letter B, which is secant theta. Because secant theta, or let's specify the theta here, secant of 2 pi, or you can do it without parentheses. We have the secant of 2 pi thirds is equal to the reciprocal of 1 over cosine of 2 pi thirds. And the cosine is negative 1/2. So we will have here 1 over negative 1/2. We can write this as 1 over 1. So we could apply here the keep, change, flip method. 1 over 1, change the operation to multiplication, and flip. Okay? We're going to flip our, or reciprocate our denominator. That's 2 over negative 1. This would mean that our secant of 2 pi over 3 on the given condition, okay, is negative 2. We're able to solve letter B because we already finished with letter A, and that we're able to finalize the identity of our cosine theta using the conditions. And let's have the last one. Hopefully I have enough spaces here because that's tangent theta. We know that tangent theta is the ratio of sine, or let's specify the theta here because we're already sure about what the theta is. So 2 pi over 3. Okay. So this is a combination of sine 2 pi over 3, okay, over cosine 2 pi over 3. Our sine 2 pi over 3 is square root of 3 over 2. Our cosine is negative 1/2. Keep, change, flip method. Sorry for the spaces. You have square root of 3 over 2. Change the operation to multiplication. And you have here reciprocal 2 over negative 1. We cancel that. When you number the negative sign, our tangent 2 pi over 3 is negative square root of 3. So this is how we solve items like this. We just need to really look into the composition of cosine and sine being the x and y coordinates of our terminal point. And from that, we'll work it step by step to solve for the rest of the items. Thank you for watching.